Okay, all right, so last time we did FOIL, we did like remember the first x times x is x squared, outside would be 3x, inside is 2x, and last would be 6. So we multiplied that, we combined the 3x and 2x to make it 5x. So when we're factoring, we're going to go back from the multiplied out form to the two factors, all right? And when the first term is just x squared and doesn't have anything in front of it of 2x squared, it's actually pretty easy. So the way that you can think about it, like this last term, 6 is the product of 2 and 3 is the product of the two guys. And the 5x, if you look at it, 2 plus 3 is 5. So the sum of them is the middle term, right? So the last term is the product of the terms, the sum. So what you're going to do, the factor, we work it backwards, you focus on the last term, which is 6. Now, the x's, you just split this x squared. One is an x and one's an x. You have another option, right? This x times x is x squared. All right, so what you're going to do is you look at the factors of 6. So see how she's written down all the factors here? So 6 times 1 is 6, and 2 times 3 is 6. So I want to find a pair that adds to the middle number. The middle number is 5. So I look at those, well, 2 plus 3 is 5. So they're my factors, all right? So I will put a plus 2 and a plus 3 in here and come factor.
Yeah, but you can do 4 and 1, but that's not right.
Huh? No, because 4 and 1 doesn't multiply to 6, right? It has to multiply to 6, right? Starting the factors, okay? So the only factors are 2 and 3 and 1 and 6. All right, good? All right, and you can always check these by FOILing them, right? Once I factor them, if I FOIL them, right? Just to check this one. So if I look at this, first are x squared, outside 3x, inside 2x, and last are 6. And you can combine these, and you're going to end up back up with what you started. All right? If you don't end up with what you started, you factored it wrong. Okay? All right. So we're going to factor some of these. And these are the easy ones because the first term is 1. So the way that I teach this is I say pretend there's a 1 there. Just multiply them. I multiply the first and the out and the last. So 1 times 4 is 4. So I need factors of 4 that add to -3. I need to find two numbers that multiply to 4, -4. Sorry, it's a negative. It's a -4. I need factors of -4 that add to -3. So find these factors of -4. All right. So I can try -2 and 2. Does that add to -3?
-1 and positive 1.
Right, I gotta find a pair. So what's the other pair? Good, -4 and 1, right? That's going to add to -3, right? So I know that -4 and 1 are my factors. You just write them down. Split the x's, x minus 4, x plus 1. Okay? Not factors. And I can check it by multiplying. I'm not going to do that, but you could do that, right? If you're unsure of yourself. By the way, just to mention graphing calculators, you could graph both of them in calculator and they'll be on top of each other. Right. Okay. The same graph. All right. So let's try this next one. I need factors of 4 that add to -5. Good. -4 and -1. That's all I need to do. So this is x minus 4. X minus 1 on 5. Okay. Eliana, I will probably fix it. I'll see the chat. I'll fix it. Okay. You can know. I thought you were here and I thought I'd punch you out. All right. You good? All right. So let's try another one. All right. So factors of 6 add to -5.
-6 and positive
3. Good. -3 and -2. That's all I need. Right. Once I got those, I'm essentially done. X minus 3. X minus 2. So write them down. Okay. All right. Next one. Factors of -6 that add to -5. -6 and -6 and 1. this factor is x minus 6. All right, do the next one on your own. We'll take a second. Do the next one on your own. Okay. Who wants to tell me what they got?
Negative 5 and 2.
Okay, good. All right. So there's the thing. All right. So x minus 5, x plus 2. All right, because negative 5 and 2 is 3. Now, if you have trouble finding factors, these are pretty low numbers, but if you have trouble finding factors, use a calculator test. All right, let's say I didn't know that all the factors were negative 10. All right, so I can find it on the calculator by doing the following. Go to the calculator, go to y equals, and type in the number you want to find factors of. So in this case, it was negative 10. So I'm going to type negative 10. And whatever it is, I'm going to divide it by x. All right. If I divide it by x, what that's going to do in my table is going to give me a list of all the factors of negative 10. So I'm going to go to the table, look at the second graph. You can see here's a list of all the factors. 1 and negative 10, 2 and negative 5. Forget the ones. 3 is not a whole number. So forget those. 5 and negative 2, 10 and negative 1. So all the factors are there in the table. So if you have trouble, like you couldn't remember the factors of 64, this is the way you get them. All right, you guys clear that online? You see my calculator? Okay, good. All right, so let's try this next one. So I need factors of 10 and add to 7. So that would be what? 5 and 2. 5 and 2. So x plus 5. X plus 2. Okay. Here's the one that everybody forgets. Let's see if you guys remember it. Factors of 10 and add to 11. All right, good. It was too good. All right. Don't forget about 1, right? Because 1 is a factor of 10 as well, right? 1 plus 10 is 11. All right, so these are the factors. X plus 10, x plus 1. Okay. Now, factors of, let's see, negative 12 to add to 11 would be what?
12 and negative 1.
Not quite.
What?
Oh, yeah, yeah. I was seeing a negative 11 that wasn't there. Yeah, okay, 12 and negative 1. You're right. All right, so x plus 12, x minus 1. All right, you guys okay down online? All right, now, before I jump into the next section, I'm going to give you a little primer on Gary's method. This is, I talked about it on the video 4.1. I like the method because I think it's easier. I think most people struggle with it because what you chose to do in your notes. And I do a little primer on doing it in your head. If you do your head, that's great. But I like Gary's method. So I'm going to show you Gary's method. I'm just going to tell you if he makes you show your work, you're just going to erase one stuff. Okay. All right. So what you're going to do with Gary's method. Gary's method, when you have quadratics that don't have just an x squared out front, yeah, because it's just a little bit. All right. So I'm going to make one up. All right, we'll do this one. I want to factor this one. So this one is just a little different. You see the other two out front? So I do what's called Gary's method with this. There's, like I said, about 5 ways to factor these. What I do is I multiply the first and the last. So 2 times negative 9 is negative 18. I want to find factors of negative 18 that add to the middle term. Okay? So what do we have?
6 and negative.
Good, 6 and negative 3. So hold on to those. All right, so I call this kill the copy. You're going to copy and you're going to kill. You're going to copy things down and you're going to kill the common factor. So what you do is you take the 2 in the front and you copy it to the front of each one of the set of parentheses. So you're going to put it inside. You're going to, instead of and x, you're gonna put a 2x and a 2x, right? Now, the way it is right now is wrong, but we're gonna fix it, all right? So you put 2x, 2x, then you write the factors down, plus 6 and minus 3. See what I did? So I copied down the factors and I copied the 2. Okay? This is not correct. I have to fix it, all right? The way that I fix it is I look at each set of parentheses, look what's in there. And I kill the common factors. I look for common factors. So look at this first set, 2 and 6. What's the common factor? 2. So what you're going to do is you're going to divide each of these by 2. Okay? The second set, 2 and 3, is there a common factor? No, so we leave it alone, right? There's no common factor in either one. So if I divide by 2, I get x plus 3, 2x minus 3. I am now factored. All right? And this is Gary's method, all right? Now, Mallards doesn't like this step, this particular method, so you know what I'm going to do with our Mallards? I'm just gonna erase that step and I do it in my head. Okay? All right, let me go back. But there's nothing wrong with it. He shouldn't like it. I mean, he says it's not mathematically correct, but that's correct, but never mind. So, you know, and I found that most people like this. All right, so we're gonna try another one, and like I said, there's a whole video on this in 4.1. So let's make up another one. Let's do. All right, let's do this one. Okay, so we're going to do this one with Gary's method. This is 4.1, like I said, there's a whole video up here. Please watch it. All right, so multiply the first and last. So 3 times negative 8 is negative 24. So in factors of negative 24, then add the 2. Sorry. Huh? Say it wrong.
6 and 10.
Well, that negative 6, but 6 and negative 4. Right? All right, so you got your factors. So first step, copy. The 3 is copied to the front of both of these. 3x and 3x. Write down your factors. All right, now this is not correct until I fill the common factor. All right, what's out the first set? 3, so just divide it out. X plus 2. You can take anything out of the second set. No, it's leave it alone. Okay? Sometimes you will be able to take something out of both sets, right? So whatever comes out, take it out. Normally you put that out front with Gary's method, just kill it. All right, kill the common factor. Okay? That's my method of factoring that I like. Okay? And I don't really think that the point of this is to factor quadratic. I mean, yeah. So like I said, there's like 5 ways to do it. This is one method that, you know, I like it. So. All right, so there's a video on 4.1 on that, so I would suggest you watch that. All right, so we're going to move on and talk about the difference of squares. I think on Tuesday when we did section 1.2, when you multiply the stuff out, when you have like a 3x plus 2 and 3x minus 2, and one's positive and one's negative, the outsides and the insides are always going to cancel. So like if I FOIL this, I would get 9x squared, the outsides would be minus 6x, the inside would be plus 6x, and those are going to cancel each other out. And then 2 times negative 2 is minus 4. The thing that we ended up with, 9x squared minus 4, is called a difference of perfect squares. Okay, the word difference means subtract, right? And squares are things you can take square roots of, right? So, and those are what we call squares. So, to go the other way, all you have to do is you take the square root of each number. So, if I have a squared minus b squared, the square root of a squared is a, square root of b squared is b. So, one is a plus b, the other one's a minus b. All right? We'll be doing some examples. I suggest you can get that to memory. Just going to use it over and over again. It's just something to know if you don't know it already. Remember in high school? Hopefully. Yeah. Okay. Now, I want you to notice something really, really important. There's a rule of factoring a difference in squares. However, a sum of squares is prime and can never be factored. All right? So if you think about it, there's a reason for that. When things are factored, they can equal 0. If you take a number of squared and add another square to it, it's never going to equal 0, right? So it never factors, right? So whenever you have a sum of perfect squares, you do nothing. You say it's prime. Whenever it's prime, it only factors itself in 1. That's the same with the expression. Right. So let's factor difference in squares. So all you have to do is take the square root. So the square root of that square root is x, and the square root of 9 is 3. So one would be a positive 3. The other one would be a negative 3. See how these are always the same. One's plus, one's minus, and then we're done. Okay, so this is the easy ones to factor. Okay, x squared minus 16. You guys tell me how to factor.
X minus 4, x plus 4.
Good. X minus 4, x plus 4, right? Super easy. Okay, difference in squares are easy. All right. What about 4x squared minus 25?
2x minus 5, 2x plus 5.
Good. You have to take the square roots. All right. Let's try this one. What about 49x squared plus 36?
7x squared.
It can't be.
Yay! All right, gold star. Why can't it be? It's a sum of squares, right? Remember, it's really easy to put that, plus and minus. We get sum there, and you never factor. Okay? So it's prime. All right, because of this plus, it's prime. Okay? That's the mistake. Okay. All right. When you look at number 5, but there's one thing you factor you should always do first. And that's take out the common factors. All right, so no matter what you're doing when you're factoring, take out the common factor first. So look at 98 and 50. Is there a common factor? There's something I can take out of there? 2, right? They're both even, right? So I'm going to take out a 2. So what I take out, I divide by. So 98 divided by 2 works out to be 49. This is 25. So now that I took out a 2, look what I have. Now I have a difference of squares, right? So I just take the square roots. What's the square root of 49? 7. What's the square root of 25? Yeah, so it's 7 minus 5x. 7 plus 5x. Okay. So here,
Does it matter the order you put it in? Like,
no, right? Because 2 times 3 is 3 times 2, right? So you can put any of those 3 factors in. I mean, you should put it in the right? I'm not really
you have to have it. That 2 has to be out there.
yeah, because that's part of the expression, right? If I take the 2 away, then this doesn't equal anything. Okay. Okay. One time you can take it away is with my very stuff. Right? Okay. All right, what about the next one? What's the square root?
8x squared.
8x squared, right? The square root of x to the 4th is x squared, because x squared times x squared is x to the 4th, right? And 81 would be 9y, right? And then we'll put a plus there. Sometimes, once you factor a difference, this might be a difference of perfect square, but it's not, because it's not perfect square, but it might happen if you factor twice. All right, we're going to do squares. So what we're going to do is we're going to go back up. So that's the end of it for today. That's what value 2.2 is on. And we're going to go back up and talk about profit, revenue, and cost. We'll be talking about this in 13.4. I guess you haven't yet, but you will. So we'll do a primer up. Okay? All right, so that, let's see what these. Okay, this is like this business application that you're gonna see. In 1324. There it is. All right, so it's on page 34 in the packet. Oh. All right. So here's the deal. With businesses, the bottom dollar is profit. I need to make a profit if I'm a business. Okay. Cost, revenue, and profit. A cost is what it costs me to manufacture my product, all right? If I'm selling basketballs and it costs me $2 a basketball, that's a cost, right? Cost is not what it costs you, it's what it costs me as a business person, right? So you are thinking like a business owner, all right? The revenue is the money I take in. So basically, if I sell the basketballs for $5 each, I'm taking in $5 times the number of basketballs I sell. The revenue is the money I take in. The profit is I take the revenue minus cost. The profit is how much money I get to net. All right, we want the profit to be positive, right? Profit's negative, we don't tolerate that for so long. All right, so let's talk about all this stuff. All right, so cost. Cost is the total cost of producing, right? It's not the cost to the consumer, it's the cost to the business, all right? So there's two types of costs associated with cost function, variable and fixed, right? A variable, if I'm making basketballs, I gotta buy so much rubber. And the more basketballs I make, the more rubber I have to buy. So that's a variable cost because it goes up with the number of basketballs, all right? A fixed cost is I gotta pay rent every month. I gotta pay $1,000 a month in rent. That's not gonna change no matter how many basketballs I make. That's a fixed cost, okay? So your cost consists of variable and fixed. So the variable is basically the cost per item, how much it costs me to make them, and the fixed is the same, right? No matter how many I make. Okay? So variable cost is that varies with the number of basketballs I make or whatever. All right, so fixed don't vary. So this is the cost function. She wrote it this way. F is what they call the fixed cost. All right, C is the total cost in dollars. This is money. It says C of X, right? It's not C times X, right? The of is punctuation. B is what they call the variable cost. It's how much it costs me to make whatever it is in 1 unit. All right, so, and then X is the number of units. All right. Sometimes you'll see it written this way. I'm kind of surprised she wrote it that way. The variable cost is how much it costs me to make an item. The fixed costs are like my rent with my employees, right? How much it costs me. All right, the word marginal. Marginal cost, you're going to see that in 1325. All right, and I'll tell you whenever you see this is my hint for 1325. Whenever you see the word marginal, you take a derivative. Now, you don't know what a derivative is yet, but you will. When you see the word marginal, you take a derivative. The marginal cost is the additional cost needed to produce or purchase one more unit. All right? That's how much it's going to cost me to make one more unit. So, for example, if a firm can produce 150 units at a total cost of $5,000, 151 units for $5,100. All right? My cost went up $100, so my marginal cost is $100. How much it cost me to make one more unit? All right? So the word marginal is always how much it costs me to make one more. Okay? Calculus is here. And by the way, another word for derivative is the slope of the line. Okay? The rate of change of line is how much it costs me. Right? It's really, at this point, because it's linear, it's a straight line, the variable cost is the marginal cost, but that may change. All right. Revenue, so we got cost. So cost is the money I'm spending. Money the business is spending. Revenue is a simple thing. Revenue revenue is the money I take in from my sales, right? So if I sell the basketballs for $5 each, the revenue is $5 times the number I sell. All right, so basically it's the price, revenue is the price that I sell them for times the number I sell. All right, that's the revenue. That's how much money I take in. That's that right here, price times the number I sell. PA is the price. Equals price, X equals number of items. All right, so revenue is not that meaningful. What the bottom dollar is in business is profit. All right, so if I take the money I take in minus the money I spend, that's my profit, right? So the money I take in is revenue, the money I spend is cost. So revenue minus cost is profit. All right, revenue minus cost is profit. That's how much I get to pocket in the end of it. All right, one thing I want to mention that we'll see in a minute. One important quantity is what they call the break-even quantity. That's when the profit is zero. So I'm either losing or gaining money. All right, so the break-even point, where I'm breaking even, is where the profit equals zero. The revenue minus cost equals zero. That means the revenue equals the cost at the break-even point. What I'm taking in equals what I'm spending. So I'm now breaking even. I'm not losing money. I'm not gaining money. When you first started business, you may lose for a few years, but you will get to the point where you make money. Right? My husband's brother started a company that was what they call capital venture. So these investors invest money in companies up front. And then they turn you loose, and eventually they start making money. You make enough that if you pay back the investors with their interest, the investors get out, and then it becomes your business.
Shark Tank.
Yeah, well, that's what they did. I mean, the company started off like this BSI to hearing out. But when I first knew his brother, there were less than 9 employees. There were 7 in California. There were 7 employees, and we had a softball team. So my husband and I had to play on the softball team because we didn't have enough employees. And now they got like, I don't know, they got like, I mean, they're even here, I mean, but they got California here. I don't know where, he's in Florida a lot, I don't know, other ones in Washington, so. But it all started with, capital venture, where they invested money in it, California, right? So, all right, so, let's talk about, let's do a practical problem. All right, John makes plans to sell lemonade. He spends $60 to build a stand. We'll stop there. What is that? Cost, profit, or revenue? Cost, right? Is it fixed or variable? It's fixed, right? It's going to cost me $60 no matter how many pieces of lemonade or how many glasses of lemonade he sells, right? All right, so the cost is the same. So they're telling you that's fixed. All right. He has another variable cost. The amount of water, lemon, sugar, and paper cups these will vary according to how much lemonade he sells. He will spend more to make 105 cups of lemonade than 5, obviously. He figures out that it'll cost him 20 cents per cup. So that's his variable cost, right? It depends, it's per cup, it depends on how many cells, how much it's going to cost him. All right, and he's going to sell his lemonade for 50 cents a cup. So what's that 50 cents a cup represent? That's what, it's not profit. It's revenue, right? Because he's going to get that per cup and you have to take off the costs. Okay, and that's profit. All right, so let's set up a table here. So if he sells 1 cup of lemonade, it's going to cost him 20 cents, right, for 1 cup. And his fixed costs are what? 60. So the total cost is going to be $60.20, right? All right, so he's selling them for 50 cents, right? So what's his revenue? He sells 1 cup. What's revenue? How much money do you get?
25 cents.
50 cents, right? It's only 50 cents. He's selling for 50 cents, Let's talk about profit. Profit is revenue minus cost, right? If I do 50 cents minus $60.20, my profit's going to be pretty darn negative, right? It's going to be negative, what is that? 59.70, is that right?
With
So if he only sells one cup, he's out $59.07. Okay, I get it. Okay. All right, so let's see, what if he sells 2 cups? Well, how much is it going to cost him for 2 cups? 40 cents, right? 20 cents each. Fixed costs are still 60, right? So the total cost would be $60.40, right? What's his revenue for 2 cups? $1. He made $1. Okay. I'm still losing money, right? I'm losing a lot of money. All right, so $1 minus 60.40 is negative 59.40, right? Not good. Right? I'm not going to do all these. Let's jump up to 5. Let's see if that's any better. All right, so if he sells 5 cups, how much is he going to, what's the variable cost for 5 cups? It's $1, right? 5 times 20 cents, right? Fixed costs are still 60. Total cost 61. All right, what's the revenue? So 5 times 50 cents.
250.
250. Ooh, now he's going in the dough. He's still got a negative profit, right? So, what do we got? Negative 58.50 is okay. Profit, right? He's still down a lot of money. All right, what if he makes, let's just try 50, because I mean, this is not going anywhere fast, right? So if he does 50, what's 50 times 22?
No.
$10. Okay, so it's going to cost him $10 plus the 60. Those costs are now $70. So let's see, if I do 50 times 0.5, what do I get? 25. I'm still losing money, right? My costs are more than my revenue. Plus 25 minus 70. Negative something.
Negative 45.
45. All right, now he's losing $45. All right, let's try 100. So what's 100 times 0.2? What is it? 200? Oh, yeah. No. Right? No, 20, right? 20. 100 times 0.2? Is that right?
Yeah.
Okay. And fixed costs are still 60. This is 80. And if he sells 100, 100 times 0.5 is 50. So he's losing $30. All right, he's still losing money even at 100. All right, let's try 200. All right, 200 times 0.2 is what? He has 40, isn't he? Yeah. 40? All right, and then fixed costs are 60. Oh, he's gonna make $100 now, right? All right, so his revenue is 0.5 times the number he sold, which is 200, which is 100. Oh, what happens here? What's the profit? Zero. All right. So at this point, he's breaking even. It tells him for him to make a profit, he has to sell his 200 cups. He's not going to do that. He might want to consider making a cheaper lemonade stand or up in his price. All right, so let's see what happens with 300. So if he sells 300, 0.2 times 300 is 60. All right. And then the revenue, half of 300, 150. So see now it's switched 150 minus 20. This is positive now. Finally, he's going to make $30. Okay. All right. They work through this stuff. That's why I don't make enough gateways at Christmas so they can figure out how much they need to make to maximize the profit. We're not even talking about maximizing, but they do that. All right. Okay. When the profit is negative, you're losing money as a business. When the profit is positive, you're gaining money. You really want to gain money. All right, so let's work some more problems. We're not going to work all of these because they're so much the same, but I actually found it interesting to do it. All right, so they tell me that the cost function is this. So let me ask you a question. How much does it cost cost for you to produce an item? Per item. How much per item? Somebody online can answer that. How much does it cost per item? No? It's all built into it. Go back up and look at the top of the notes. Look at the variable cost. 80 cents, right? 80 cents is per item. If I didn't hear you, I'm sorry. All right, what's 100? Represent.
Fixed.
Fixed cost, that's what's gonna cost you no matter what. All right, and what about the $1.20 here? What's that represent? Huh? Revenue, that's what I'm selling it for, right? I'm selling it for $1.20, this is the price. All right, so they want R of X minus C of X, so in other words, they want the profit, right? So if I do R minus C, the revenue is 1.2X. When you subtract these parentheses around C, because you have to distribute the negative, all right? I thought it long enough, I see that. So I'm going to minus 0.8X plus 100. So that minus distributes through there. So that's 1.2X minus 0.8X minus 100. That 100 needs to be subtracted, okay? People forget it all the time, they add it, and then they got problems. All right, and you can combine like terms. 1.2 minus 0.8 is 0.4X minus 100. All right. Okay, now the second example, B, I want you to try that on your own. So come up with an expression of revenue minus cost, all right? Go on your own and then we'll see if you got it right. Okay, you guys get done with it? You can tell me what they got. Wants to be brave.
No, 11.60X minus 1,800.
Wonderful. All right. They were multiplying last period. You guys did better in last class. All right. So you guys just subtract them, right? So we're going to just work it out. So it's revenue, which is 14.8X. If you want, you just change the signs of these. Minus 3.2X minus 1,800, right? That's what I do when I subtract it. Just change signs. 4.8 minus 3.2 works out to be 11.6. Okay? Everybody go down online? Okay. Wait, I'm going to skip C and D if that's okay, because it's the exact same problem over and over and over. It's really rude. You guys okay with that 6 C and D? That's the same. Okay. So now we got a whole bunch of questions. I'm going to see what you guys can do with this. All right. So they gave me a cost function, they gave me a revenue function. Question A, what's the significance of the 0.8? What is that? It's the cost of what? Per item, right? It's the cost to make an item. Cost per item. All right, what's the 1.2x? 1.2 in revenue. It's the price, right? It's what you're selling it for. Price per item. All right, the C of 50. So when you see the parentheses, they're telling you to plug in 50 for X, right? So let's find it first. So C of 50, you're just going to replace X with 50. So let me do this. It doesn't mean times 50, it means of 50. And plug it in here. All right, so if I work that out, it's going to be 140. What you guys get? All right, so what does it represent? What do you think it represents?
How many they sold?
That's not, yeah.
So what? It's not the cost per item. And that's what they sell. What did you say back here?
That's what, how much they sold or what they sold.
It's to produce what? It's the cost to produce how many?
50.
50 items, right? So C of 50 is the cost for this 50 items, right? So the number on the left here is dollars. And this number here, X, is the number of items, right? When we plug in 50, it's the cost for me to manufacture 50 items, right? Remember, it's always from the business standpoint, right? From the business math, for the business. All right. So what is R of 50 equal? So I'm going to plug that into R. So here's R, right? I'm going to set X equal to 50. So if I do that, what do I get? What do I get? 60. So what does it represent?
Which they make off
Yep. It's not much, not profit, but it's how much money I bring in, right? So this tells me if I sell 50 items, I get 60 bucks. Right? That's my revenue. So I'm going to say I bring in $60. And here it cost me $140 to make 50. Okay. So what about profit? So how do we say what profit was? To find profit, what do we do? What's profit?
You multiply the variable cost times the cost of the item.
Okay, so simplify, all right? If I tell you I'm taking this much money and I'm spending that much money, how do I find my profit? Subtract them, right? Okay, that's it. It's revenue minus cost, right? So for 50, I already got it. So P of 50 will be the revenue minus the cost, which you already have. The revenue is what?
60.
60, and the cost is, if I subtract that, I get
-80.
negative 80. Because it's negative, it tells me I'm going to lose $80, right? My profit is negative $80, right? So I'm going to lose money. And I'm not happy, I'm losing money. All right, let's go through the next question. What's the total cost of this? Okay, now there's three numbers there. We're just going to use one of them. Which one do you want? 80, 100, or 300? 80? All right, so the total cost to produce 80 items. So what we're going to do is the total cost is right here. Remember, X is the item, C is the money. So I know that my cost equals 0.8 times 80 plus 100, right? That would be my cost. So what's that going to be? That's going to be 64. It's going to be 164. Is that what it's on the backwards? Right? Yeah. Yeah. Okay. So it's 164 bucks. Remember, the thing on the left is the money. The thing on the right is the items. This is money too. All right. How many items can be produced or purchased with? Now, I'm just going to use one of those numbers. Let's use 500. All right. Now, when I'm talking about how many can be produced, am I talking about cost, revenue, or profit?
Cost.
Cost, right? The $500 is not the X, right? The $500 is the money. And I'm solving for X and I'm right, right? So what I'm going to do is take my cost, I'm going to set the cost equal to 500. Right? And that will tell me really how many I have to produce. I'm solving for X in order to get that kind of cost. So if I subtract, I'm 500. If I subtract 100, we get 400 is 0.8x. So we're going to calculate what's 400 divided by 0.8. 500. All right, so I've got to make 500 items. I can make 500 items. All right, let's look at this. What's the revenue? Revenue from the sale is 60 items. So revenue is R, right? So R equals 1.2x. Where do I put the 60 for R or S? Is it revenue or the items? That's what you're asking yourself. It's 60 what? Items, that's X, right? Items is X, right? Revenue, cost, and profit of dollars. So they're plugging 60, so it's 1.2 times 60. So somebody with a calculator, tell me what that is.
72.
72? All right, so that would be $72. All right. All right, how many items must be sold to bring in the revenue? We'll just do 600. I don't do all of them. All right, so revenue, I'm going back to revenue, right? So where am I going to plug in the 600 for R and S? R, it's money, right? So 600 equals 1.2x divided by 1.2. So somebody with a calculator take 600 divided by 1.2. How many would you get? 500. All right, so I gotta sell 500 items. Remember that X is the items, R, P, and C are the money. All right, this is the last thing we're gonna have to do. So what's the break-even point? Let's see if you guys remember.
Comes up like,
Huh? Sorry, say it. What?
it's gotta come out to 0.
What equals 0?
R or, I mean,
R.
oh, you don't go over your profit, if you're not making.
Right, so your profit is 0, right? But your profit is 0, which means your revenue and costs are equal, right? So to find the break-even cost, you set the revenue equal to the cost, right? So how you do that, the revenue is 1.2x, revenue to cost. And the cost is, what's the cost? What? 28x plus 100. All right, so this is what I have to solve. It's a little bit of algebra. All right, so I'm going to move x's together. I'm going to minus 28x. I end up getting this is 0.4x. This is 100. Divide by 0.4. So somebody with a calculator do 100 divided by 0.4. So 250 items are what I need to sell in order to break even. That's where my profit equals my, I'm sorry, where my revenue equals my